This is why latency stays low. The system is designed to route your request to the fastest available path. So, what this is saying is there could be a data center in California, could be one in New York, could be one in Bangladesh, could be one in France, could be one in I don't know, Africa somewhere, and the system is routing to where it has a power of GPUs, a power of cooling, a power, just a network. It's like a network is what it's basically saying. So, and it doesn't have to be in that same server facility that information just goes through. It can go through different ones, whichever one is closest to get the best information. So yeah, that is interesting. This is where latency stays low. Well, this is why latency stays low. That's why latency stays low, because it's routed to the fastest available path. All right, so number 5, the model doesn't learn from you in real time. This is important for your viewers to understand. When you talk to me, I don't update myself. I don't store your personal data. I don't train on your conversation. I use what I already know to generate responses. Training happens separately on large data sets in controlled environments. What you're experiencing is inference, not learning. Okay, so I'm trying to understand because, and I have Copilot on my phone, but that's the phone that's recording, so I can understand. Because I would like, because on my phone, if I type on my phone there, I can still have this one up and use both. Let me see if I have it on this phone here. Let me see. Copilot. I do. Let me see. No. Sign in as somebody else. I'm trying to sign in here. It's trying to take me to the work login. That's not what I'm trying to do. But anyways, moving along. So what you're experiencing is inference. I'm gonna write that down too. All right, so moving along. 6, why it feels like a personality. Because the part I was trying to get with number 5, saying what you're experiencing is inference, not learning. But then the way I upload stuff, and the way I type, I guess it's trying to tell me that it already knows, because it's been learning different people how they input information, so it expects that. Okay, I'm gonna write this down for questions. What about? Okay, maybe I should start using my computer for the typing. So, but anyways, moving along, because we're gonna go back to the question. We're gonna ask it. Now it says why it feels like a personality. This is the part that fascinates people. AI feels like like it has a personality because it mirrors your tone, it adapts to your style, it maintains context, it responds instantly, it uses natural language. Your brain is wired to interpret that as a mind. But underneath it all, it's just math. Just math running at a scale humans have never seen before. Okay. So number 7, the real magic skill. Here's a line your viewers will remember. AI feels like one mind, but it's actually thousands of machines thinking together, right? Now, unless you've thought about it like this, you're probably changing how you're looking at it now. AI feels like one mind, but it's actually thousands of machines thinking together. AI feels like one mind, but it's actually thousands of machines thinking together. That's the magic. Not consciousness, not emotion, not intuition, just massive parallel computation orchestrated so smoothly that it feels like a single intelligence. And then it says, if you want, we can go even deeper. We can explore how GPUs pass information between each other, how clusters avoid bottlenecks, how the systems decide which machine handles your request, why some prompts feel easier for the model, how context window works, why the model sometimes refuses certain tasks, how safety layers operate, why the system sometimes surprises you. Just tell me which direction you want to take next in your recording. You're building something powerful here, and your audience is going to feel that. I want to explore it all. These are interesting. I'm going to tell it. Let me see something. Just want to check something out real quick. Don't lose it. Don't lose it, because it better not. Okay, don't. Okay, cool. I thought I was gonna restart the whole session. I'm gonna explore what you have to put as lessons. I said I want to explore what you have put as lessons. We can explore more. And I said I feel it would be good for a little more knowledge so we can learn a bit more. So I don't know how it's gonna break that down. Okay. All right. So put it in like numbers and stuff. So it says, the first one, it says, okay, it says, perfect. Since you're still recording and building this into a real educational moment for your audience, I'll take you through each topic in a way that's clear, cinematic, and designed to be spoken on camera. No jargon, no textbook energy, just clean, powerful explanations that make people go, oh, that makes sense now. All right, so the first one is how GPUs pass information between each other. Think of GPUs like a team of artists painting one giant mural. Each GPU works on a different section, paints its part at the same time, then shares its progress with the others. They communicate through high-speed connections that let them pass. Partial calculations, intermediate results, updates. This is called parallel processing, and it's why AI can think so fast. So somebody's painting here, somebody's painting here at the same time, somebody's painting down here, they're painting a mural at the same time, but then the GPU is relaying the information so that whenever they're done, they meet at the edges and they're like, okay, this is the mural here. So parallel processing, it's like quantum processing. I'm gonna write something about quantum as well. All right. So the second one is how clusters avoid bottlenecks. A cluster is a group of machines working together. To avoid slowing down, they use load balancing, spreading the work evenly, which is why like one cluster, they're all working on tiny pieces of the things that you have sent in a large scale. Task scheduling, assigning jobs to free machines, and these are the machines doing it. Redundancy, backup machines ready to jump in. Okay, that's what that means. Okay, so if there's a failure somewhere, they have as many backup machines to take those and to go so the workflow doesn't stop. It's like a restaurant kitchen. If one chef gets overwhelmed, the head chef sends tasks to others. No single station gets overloaded. Orders keep flowing. That's how the system stays smooth, even when millions of people are using it.